The next section I wanted to cover in terms of, if you're a company who wants to take advantage of some massive opportunities, is the way you build something often matters as much as what you're building in the first place. This is an example of a vertical takeoff and landing vehicle. If you have a good idea in aerospace, you have to certify it, right? And the only way to certify it is to get what's called an airworthiness certificate. And the only way to get an airworthiness certificate is to be able to prove that the plane can actually fly under extreme conditions. And a lot of digital modeling is happening here, right? The digital modeling is something that the hardware world is learning from the software environment, right? With the cloud and DevOps and Agile. And on the left-hand side that's playing around is actually a physical model that actually has to be built eventually for ground testing and for flight testing, but most of the energy is actually being spent in creating digital threads and digital and virtual environments so you can study the propeller and you can study the blade design. You can make decisions on the propulsive systems. You can understand the pressure profile of the winglet and make decisions. These are all disciplines that are coming from the software realm, right? How do you do that in simulation? And I think there's going to be a lot of collaboration between the software world and the hardware worlds. Another example where the software world and the hardware world are collaborating is, we typically need machine learning experts to put together a predictive model. You have something in the wild and you want to predict its failure. In this case, this is a fuel cell. We talked about clean energy. Right? Clean energy, you need chemists and you need folks who understand fuel cells, but you need software engineers who can create predictive models to make sure that these parts don't fail. In this case, you can see with the red dots that the compressor for this particular fuel cell, and it's a complex system, right, is failing under certain conditions. And a predictive model was developed by the machine learning experts. When does the crossover happen? Well, that has to be shared with the design team, right? Why am I going to live with a fuel cell that fails under certain conditions? So how do you expedite the exploration of new design options in the hardware world? Well, you need the data scientists to feed these types of results back into the design team, right? So complex product that needs both software and hardware.